Welcome
Alright,
back
ready when you are.
to day 32 of LeetCode grind. Solve or go home. 30 minutes. Solve or go home. Okay. You already did today's?
Yeah, it's a little tricky. I would say spend more time on analysis and then your coding will be very easy.
Sure. Okay. So given an array nums of n integers, your task is to check if it could become a non-decreasing by modifying at most one element. We define an array as a non-decreasing if nums I is less than or equal to nums I plus 1 holds for every I 0 base such that 0 less than I less than or equal to n minus 2. Basically, okay, so what it means is you can change one element and then it has to be in ascending order, right?
Yeah, yeah.
Okay. So, wait, how's this tricky? What literally you're only allowed to make one change, so you just loop through the array, and then if you see two numbers that are out of order, it's false. If it's more than two, it's false.
Right, right. So that's a majority case, but then there's some tricky edge cases.
Like such as what?
So you're correct. You already have something that's like mostly sorted, and if you have anytime there's two out of place things, you're
You can't do it.
you definitely return false.
Yeah.
What if
Anything over one.
anything over one? That's right.
Mm-hmm.
Will return false, and then but then there are a bunch of cases where with one you will encounter the issue of uh, it looks legit, but it's not legit.
Wait, why is that? Okay, so you can modify it. It doesn't say you can't modify it to whatever you want, right? There, there can be duplicates, right?
Yeah, there can be duplicates. That's not a
Oh,
problem.
is that why there's? Okay, I see. Okay, so if you have an array, so let's say like you got I don't know, like five. Let's just do it normal. One, two, five, three, four, like this, right? This scenario you couldn't, because then if you change this to two, it's not increasing. You change it to three, it's also not increasing. Is this like your example of an edge case?
No, no, that's fine. If you change it, no, no. If you change it to this actually works.
Wait, if you change what?
If you change five to two or three, this actually works.
Oh, that counts. If it's equal, it's
Yeah,
fine.
this works.
Oh, okay. Then I don't see the edge case. Then what can it be?
Well, okay. Um, so in the 1, 2, 5, 3, 4 case, how many out of place things are there? It's just one, right? Because five
Yeah,
is greater than two.
yeah.
Okay. So what if instead of 1, 2, 5, 3, 4, you had like okay, you want the one out of place thing to still be the five and the next number, right? The next number can just be any number less than five, right?
Um, what do you mean by that?
Like, what if the next number was instead of three, it was like zero, for example.
Okay. So you're saying this is like this example?
Mhm.
Well, this would be undoable.
Right, but if you look at the number of out of place things, it would just be one, right?
I see. I mean, yeah, that the algorithm, if you run through this, it would only be one out of place. Yeah, you're right. Okay, so you would have to check for out of place and something else.
Right, and what is this something else?
That
That's
something
the
else is I think it's you check for out of place, and then the location where it's out of place, you check to see its left and right and make sure that is actually increasing also.
Okay, that's a good idea. So that means in the out of place. So are you saying the five is out of place or the zero is out of place?
I think in this algorithm. Oh wait, actually, if this algorithm, based on what I was thinking, it would say zero is out of place. So in this scenario, it would still work because 5 and 4 don't work out. But what if 4 was 6? Then it wouldn't detect that.
Right, if 4 was 6, then this is actually fine because you could change the 0 to a 5.
Oh, right. Okay, then that's fine. Okay. So wait, if this in this scenario, if I were to say 0 is out of place, and I check 5 and 4, 5 and 4 are also not good. So it's gonna return false there.
All right.
Is there
so,
another edge case then? I don't.
Well, this is the worst edge case, right? But as you can see, so can you write out both possibilities? It's
What do you mean?
12504,
Okay.
12534, and
125
06.
34 125. What was that other one?
12506.
06. And then was there one more? I forgot.
No. These are the ones we want to analyze, and I guess the one doesn't matter. So you can chop out. We'll leave it there. It's fine.
Okay, so in the case where it's 12504, 0 is out of place and it's fine. This one will return false for sure based on the left-right checking. In the 125343 is out of place.
Wait. What do you mean? What are you checking? 12534.
Yeah, so when you get to 0, that index is incorrect. So you're gonna store 0 as an incorrect number,
Right.
And then you're gonna check the index to the left and to the right of it, and then making sure that that is still in increasing order, because 5 and 4 is not increasing, is gonna say false.
Okay, but what about 12534?
Yeah, that's what I'm looking at this case now. So 12534, 3 is out of place. So you check 5 and 4, that's also not good. So that's also false.
But we know that that's not the case because you can change 5.
You can change 5, yeah. Okay, yeah. So this algorithm wouldn't handle this case.
Okay, and then let's look at the last one just for completeness.
Okay.
2506.
So yeah, you check 0 is out of place. It's gonna look at 5 and 6, and it's gonna say, "Oh, that's good," and then it's gonna keep going. But then technically, that would be correct because you can change 0 to 5 or 6.
Exactly.
So it doesn't handle case 2, but it handles case 1 and 3.
No, but what's different about case 2 than case 1 and 3?
Case 2 is that we're checking 3 is out of place, but technically it's the 5 that's out of place. It's the 5 that you want to flip in most cases. Actually, no, that's not true. In the first case, you can't flip the 5 because that still wouldn't get it correct. Yeah.
Okay, so in both 2 and 3,
yeah,
the index 4, which is number 3 and number 0, are the index where your out of place is increased, right?
Yes.
Okay. So then, what's special about? Actually, in all 3 cases, index 4 is the automatic index, right?
Mm-hmm.
So what's different about the first case versus the other 2?
The first case versus the other 2. Okay, the first case. Oh, I see. So in the first case, everything up to your current index is increasing, but then in the second and third case, everything up to your current index. In the first case, everything up to your current index was increasing, but now you've decreased.
Well, in all 3 cases, that is the case.
That's true. Okay, yeah. But like, how do you describe this? Actually, no, that doesn't work. Alright. So this one is supposed to be true. Yeah, so that one was false because Well, the first case is false because even if you flip the 5, 2 and 4 don't work.
Okay. Well then,
But then,
okay.
but then, yeah. So the the algorithm detects the out of place as the number after.
Okay. My question to you is, in case two, what do you fix, and why do you fix it?
You fix 5
Why do you fix it?
because that's the only way to get it to work.
Well, okay, that's technically correct, but completely useless. So why can't we fix three?
Because 3, because if you fix 3, it's still less than 5. Because then you have to have it increasing. Because then 4 to the right of it is smaller than 5.
I mean, yes.
Okay, okay. So
Okay.
I guess you have to fix the number that is that is both is greater than both sides, basically.
I don't know what that means.
It's greater than the number to his left and greater to the number to his right. That means, yeah, that one has to be fixed.
Uh, mm, Not strictly so, because in case three, index three, which is the five, is bigger than two and it's bigger than zero, but you don't fix that. You fix the
Oh,
one to the right.
right. Okay, never mind.
I'm trying to get you to figure out why one works and two doesn't work and three doesn't.
Wait,
Sorry,
wait, 3
why
does
one
work.
doesn't work but two and three doesn't.
Yeah.
And it's the key is in figuring out why you change five in the second one and why you change zero in the third.
Uh huh. 12504 12534.
Like for example, do the five was something else?
What?
At what point do you no longer have to fix anything?
For what?
Like if it was 12434, would you still have to fix it?
Yeah.
Why?
Because 4 is greater than 3.
Sure, but would you have to fix that one specifically?
Oh no, you can fix the one to the right.
Right, you could fix three to four now, right?
Yeah.
So right, but what if it was 12634?
And then you have to fix 6.
Correct. So why is that?
Well, if yeah, basically, you have to fix that one because if you fix the one to the right, still doesn't work. If you fix the one to the left, it doesn't work. You have to fix that specific one.
Right, why is that? And can we write these cases out so you can maybe like look at them and maybe come up with an idea?
Okay.
Right. So you should also write. I mean, we know these are all doable, so you should write like what should you fix? Right. Well, I mean, in line seven, you can fix three or four. Oh, sorry. I guess you should put the index that you fix, so it's more obvious.
Okay. Well, let's index 2, index 2, index 2 or 3.
Right. Okay.
And this one is index
Fine.
4.
With three, right?
No, it's 3.
And then what if it's okay? Okay. Right. So now inside of let's expand the case the last case, right?
Okay.
What if it was 1 2 5 1 6?
1 2 5 1 6. Okay. Yeah, you still have to fix 1.
Right. And then what if it's 1 2 5 2 6?
Same thing. Fix the 2. Yep. Anything up to 4. Wait, actually no. If it was 4, you can fix the 5 also. Yeah, anything up to 3. Wait, actually no. If it was no. If it was no. This one you can fix either position. You can fix either 3 or 2.
Correct. And then what if it was 1 2 5 3 6?
1.
And you're kind of
1 2 5 3 6. Yeah, you can only change position 5, which is position 2.
well, not strictly. So you could also change position 3 as well, right?
Oh yeah, you can change that to 5. Okay, yeah, you're right. Never mind.
Okay, so I guess I'm trying to get you to figure out what in what scenario or when does the fixing of something change?
Yeah, so it looks like you try fixing your current one. If it doesn't work, you look to the left. That doesn't work, you look to your right. Oh yeah, no, I think it's just in these scenarios it looks like it's always this one or the one to the left. And that's it. And if you can't change either of them, then you failed.
Okay, can you put a break in between 8 and 7, lines 8 and 7?
Okay.
So we can just stare at the bottom part. And then can you also put a break between 5 and 4 and stare at the top half? Right. Okay. So what if we were to continue on line 9, saying it's 1 2 3 3 4?
Okay. You don't need to fix anything.
Exactly.
Okay.
And let's keep the two cases separate. Okay. So and maybe order the 6 5 4 3. So switch line 6 and 7.
Okay.
Okay. So why is it that 6 and 5 you can only switch the left guy, and then 4 and 3 4 you start being able to say like, oh, I can switch either guy, and then 3 you don't switch any.
Well, in the 3 case, it's already like there's nothing out of place, so it wouldn't even trigger the algorithm. But
Sure. Then what about the 4 case?
in the 4 case, you can switch either one because the 4 wait, actually yeah, the 3 can be swapped too because left and right are equivalent.
Okay, but okay, let's not look at 3 for now. Or sorry, let's not try switching number 3. But why? Actually, we're rephrasing it wrong. Okay. How come in line 6 and 7 you can only switch 5? Oh, sorry, switch position to index 2.
Yeah, because basically if you switch position 4, it would be out of. You can't do anything to position 4. It's gonna make the thing not increasing. Like any number that you put in position 4 will ruin it.
Why?
Because the number after it is smaller than 6.
Okay, let's say you switch position 4 to 4, right?
Yeah.
And you have 1, 2, 5, 4, 4, right?
Yeah.
Right. So that doesn't solve anything because what?
Because it's wrong. It's not increasing.
Well, okay, that's clear. But which part is not increasing? What is out of place?
The 4, or I guess the 5, but
Is it the 4 or the 5?
it would be the 4. 'Cause technically 1, 2, 5 is increasing.
So you're saying the 4 is out of place,
Yeah.
but it's 1, 2, 5, 4, 4.
Yeah.
Uh,
I mean, okay, fine. If you want me to say it's the 5, because it is the 5 technically, but the algorithm wouldn't know that, because then it's checking. It goes left to right looping, right? So it goes 1, 2, 5, that's increasing. Then it hits 4, that's decreasing. So that means 4 is out of place. It wouldn't know that 5 is out of place.
Sure. So the 4 is technically out of place, but if you were to take out the one before it, everything would be in place, correct?
Yes, but it wouldn't know that unless it checked.
But okay, that part doesn't. This part doesn't matter at this point. If you had 1, 2, 5, 4, 4, what would you kick out to make it work?
Well, the 5 for sure.
Good. And why is that?
Because because it's increasing over everything else behind it.
The 5 is bigger than 4, right?
Yeah.
Okay. So that means when you're at index 3, where your 3 is,
Okay.
if you check before it and after it, what can you say?
You can say both numbers are bigger than it.
No, okay. Well, that doesn't matter. How do I do this? Okay, what's the difference between 1, 2, 5, 3, 4 and 1, 2, 5, 3, 6?
1, 2, 5, 3, 4. 1, 2, 5, 3, 6. The six allows you to change the 3 to a 5,
Correct.
but the 4 doesn't.
The 4 does not allow you to do that.
Yeah.
Why is that?
Because 6 is greater than 4. Or 6
6
is
doesn't give a shit about 4.
4 is less than anything that you can change 3 into, basically, to make it work. You can change 3 to a 5 or 6.
Okay, you're on the right track, but why did the 6 work?
Because you can change the 3 to a 5 or a 6.
Why can you do that?
Because that's still increasing order.
Right. So 6 is greater than 5, right?
Yes. So you're saying, I thought I kind of glanced over this earlier, but what you're saying is the position where you think is wrong, as long as the right element is greater than the left element, you can switch that one.
You can switch that particular element.
Yeah.
But then that might not be the only element you want to switch, because you might want to switch the element before you.
Yes.
Which is in the case of 1, 2, 5, 3, 4.
Yeah.
Right.
Mm-hmm.
If you want to switch to 5, then what happens? Right.
Mm-hmm. Which 5? Which one are you talking about? 1, 2, 5, 3, 4?
In the case of 1, 2, 5, 3, 4, why does that work?
Why does switching to 5 work?
Yes.
Because 5 is greater than 4, so you can't switch 3.
5 is greater than 4, so you can't switch 3. But then, what happens if it was 1, 4, 5, 3, 4? Let's say
1, 4, 5, 3, 4. Okay, you cannot switch anything. It's a failure
why?
because there's multiple out of place.
No. If you look at the number of out of places, it's only 1.
Oh, you're right. It's not multiple out of place.
But going
But
through the same logic, you're like, okay, I found that the out of place is at 3, right?
yeah, yes.
And then I'm gonna see, oh, 5 is greater than 4. So the one before me and the one after me are also out of place, technically.
Mm-hmm.
So that means you would want to switch that, right? So that means
No,
when you're at a given out of place thing and you want to switch the things before and after you, and then you're no good, right?
no. So when your 3 is out of place, so you're checking to see if you can replace it. But in this scenario, you can't because your right is less than your left. So you can't switch
Correct.
3. So you need to look for another candidate to switch.
Right. Exactly. So now you're trying to switch the one before you now, because if you're at a current out of place thing, that means you can either switch yourself or the one before you.
Yeah.
Right.
Yeah, exactly.
And so the one before you
It's
can you switch
5.
that?
No, you can't.
Why not?
Because your right is less than your left.
Exactly. So if you make those 2 checks at any given out of place thing, and if they're both not true, I guess.
Then you're
then you
you're
can do
done. Yeah, okay.
But otherwise, if it's in order, the reason why 1, 2, 5, 3, 4 works is because even though 5 is greater than 4, 2 is less than 3. So you can switch the 5 there.
Mhm. Yeah, so
Makes
basically what you're doing is finding the indexes of the messed up stuff.
Yes.
Then you check to see if that one can be changed by checking right and left. If right is greater than left, then it can be switched. If it's not, then you check the index to its left and see if that index right or and left is switchable. If not, then you're screwed. But if it
Right.
is,
So
then
if both cases fail,
yeah.
then you have a false.
So you have
Can you analyze?
you have 2 chances to switch at any given broken index.
Right.
Okay.
And line 4, why does that not work?
So yeah, 0 is the one out of place, right? So 4 is less than 5, so immediately you failed already.
Mm-hmm. No, but
But you can check left.
0 was
Okay,
a 3,
sure,
you'd be fine.
sure. You can check left. So if you check 5, 0 is also less than 2, so that one fails too.
Right. So if both the current index is smaller than the 1, 2 before it,
Yeah.
and the one after it is smaller than the one before it, then you're hosed. You can't do anything about that.
Yes.
Right.
Mm-hmm.
So it's a really tricky edge case, but you have to kind of figure it out from analysis, right? You're like, I want to switch it, but I can't. And so if I can't switch this one, then I have to try to switch the one before me. And if I can't switch that one either, then, well, okay, we're screwed.
Yeah. Okay.
Yeah. So, okay, now how do you code this?
So my thinking currently is a quick set. Basically, loop through O of n, build a set. If set is length greater than 1, immediately false. If it's not greater than 1, then you look into that index, check the right and left of it. If right is greater than left, you're good, return true. If right is less than left, then check. Then you pull out the index before that and check the right and left of that. And if that one works out,
So I guess be careful about returning true. It's more that when should you return false, and then if you don't return false ever, then you just return true at the end.
yeah, you could do that. I think there's only 2. Okay, yeah, I guess that's less stuff to worry about. Yeah, so I guess you return false if the set is greater than 2. You return false if both of these switchings can't happen, and then return true otherwise.
All right. So you need a case that the 2 before is greater than the current, and the 1 before is greater than the next, or anything in the middle, right? And if that's the case for any out of place guy, then you know it's false, and you can return. Otherwise, you do not know it's false.
Yeah. Except, yeah, I think you're shortening the logic by doing like a 2 before, but I'm not totally following that. So if it's 2 before,
Well, I mean, you just analyze line 4, right? Line 4, 0. You're at index 0 where the issue happens. And you're like, oh, 2 before me was a 2, and 2 is bigger than. and then one before me is a 5, and which is bigger than the one after me, which is 4. And so we know in this case, there's no way I can switch either myself or the one before me. So this is a problematic index, and I have to return false.
I see. So yeah, what you're doing is you're just okay. I think I understand like that. I understand like shit, I don't know how to explain it. I understand what you're saying, but I don't understand the jump in logic to that point.
Oh, I mean, I thought we had discussed the logic, right? So
No,
so
my logic was different than yours, but you're just like you're like appending the logic together and shortening the logic so you don't have to write so much code. Because my logic was basically check right and left for this one, and then right and left for the left one. But then you're literally just doing two ahead, and
no, that's the same thing. That's the same thing.
it is the same
So
thing.
you're
But then
saying,
my brain didn't completely wrap that yet. So
wait. So you're checking right and left for your current index, right? And you're
yeah.
told
So
if it's greater, then you can do another if inside of that. Which
yeah.
is
So
like
yeah. So basically, it was like if 3. Oh wait, so 3 is 0. So it's if 4 is greater than 5. Okay, we want the false case. If 5,
well, no, I guess you want to say if 5 greater than 4.
5 greater than 4, yeah, then that's false.
Then you check 5.
Yeah, if 5 greater than 4, then you would check if 2 greater than 0.
Exactly.
Okay, so
If both of these are true, then you return false.
yeah. So what you're saying, yeah. So my logic. This
what
was
I'm just saying is
yeah. You're just saying
5
jump
greater than
2
4
ahead.
and 2 greater than 0.
Yeah. So
So
you're
I combine 6 and 7.
yeah. You just put them into one line.
But it's the same thing. You can do both layers. It's the same logic. Whatever makes you more comfortable in coding this, go for it.
No. Okay. No. I got it now. It's just like before writing it down, it didn't make sense to me per se. Because then you were like jumping 2 ahead, but then if you think about it, technically 2 ahead is just the left of the left.
Right.
Okay, that's fine.
So what happens if the out of place index is the last index or the first index?
Out of place is last. Okay, so what is the scenario for that? So let's see. It'd be like 1, 2, 3, 0. I mean, out of place for last, I don't think there's ever an issue of switching. Because
well, the only issue is if you had another out of place before you do, right?
oh yeah, sure, okay. But that check is done
But
before
then you
this
don't
check.
have to do that funky check with
Yeah.
the
So if the set already had 2, you're already false anyways. But then like
and analogously, out of place is first.
okay, so if it was 0, I don't know, it'd be like 5. Yeah, same switch. Like yeah, it can always be switched because it doesn't have any.
Right.
It doesn't have any person before it to mess it up. So it's all.
Right. So then you now have your pseudocode, right? Like basically you're still counting for the out of place thingies, and then at the out of place you check before after, then you check. Well, if that's good, then you're fine. If that's not good, then you check one before and after, and then if both are not good, then you return false.
Yeah, and then if there is no left or right, then you're good either way.
So you just have to be careful on, I guess, arrays.
Out of bounds. Yeah, that's fine. Okay, so out of place is a set, and then for
Do you need a set, or do you need a count?
You could do a count, but I wanted to store the index so I know how to access back those numbers to do stuff with it.
Well, in this problem, you don't really care.
Wait, why not?
Because it's the index that matters.
Yes, I'm storing the index. So if you're doing a count, you still have to. How are you going to keep track of the index? Where are you storing your indexes?
No. If there's any, well, you don't need to store the index because.
Are you saying you're
just
just?
process that index if it's inbounds.
Oh, so you process as you go. You're not even going to do it all again. Oh, I see.
That's probably the most efficient way.
Yeah, that's faster because you can exit the instant you see 2 out of place anyway, right? So that's fine. Okay. Okay. But then, okay, so in that case, that means the second you find it out of place, you try to resolve it anyway.
Yes.
Even
yes.
though there might be multiple out of places in this array.
Oh, but like if that out of place cannot be resolved, it doesn't matter, right?
Yeah, but then, yeah, so if the out of place is resolved and you go down and you find another one, then you return false again, even though you solved the first one. Okay, that's fine. Okay, so basically, okay, first, if it's out of place, it has to be strictly increasing. So I shouldn't do this. I'm going to do a range. Okay, if nums I is less than nums I minus 1, then I need to do count plus equals 1, and then I'm gonna just exit if it's greater than 2 at this point before I even do any logic.
Greater than 1.
Yeah, I think greater than 1. And then
Not else. Elif.
is it? Because else would trigger. Wouldn't you want to trigger this code if you don't exit? Well, if you do, it's
sure.
it's the same. It's
Okay.
elephant.
Let's see what you're writing first.
Well, elephant else should be the same thing, right? Oh, I see why you did elif, because I was gonna do else and then another if. Yeah, that's probably cleaner then. Elif. Okay, so now that we have the current index, we check the left and the right. Okay, yeah. So if I elif, oh, I already have elif. Elif I is greater than 0.
No, we know it's greater than 0 because you start with 1.
Oh, right. So that case doesn't matter. Okay, so it's elif I less than. Wait, no, it's not greater. It's, wait, what am I talking about? It's. Oh yeah, I'm never gonna have that case, the out of bounds case for the left side because I start index 1. But I might have the.
No, you will, because if you're at the last index, then what happens?
No, I'm sorry, for the left side. I only have it out of bounds on the right side, so that's what I'm checking for right now. So if I is greater than len nums. Wait, actually, no, it's I plus 1, yeah. Okay.
Technically, that will never happen, right? Because in the range of 1 to len nums, you never hit the top number.
Yeah, but then if I'm checking right and left, it will hit that number.
No. So I plus 1 will never be greater than len nums. If you're doing I in range len nums.
Oh,
it
then
will be equal to
yeah. Oh, greater than equal, yeah. That's what we want then. So in this case, yeah, this one would be true. Actually no. So basically, I just want to check to see that this case is not hit, because then I'm returning true outside anyway. So I need an elif, not this case. I need to check to make sure it's in bounds before I do my crap.
No, so you know I is greater than or equal to 1, and it's less than or equal to len nums minus 1. So if you want it to not be the very last number, then you should just set a different condition here, right?
Well, yeah.
So how do we cut the range to be one less than len nums minus one?
I mean, we could do that. Oh wait, yeah, that's fine because, yeah. Oh yeah, okay, that's yeah. Then we don't need to deal with this case.
No. We should still deal with this case because the last number could still be out of bound. But, I don't know what the hell you're doing now.
Wait, no.
In the elif, you should check if it's in bounds.
That's what I'm checking. But wait. If the last one is messed up.
No, change the previous index back. Like,
Wait. If the last one is messed up. Okay, so yeah, I guess the count wouldn't hit 2 because the last
right,
one's messed up.
which is a problem. So
Yeah, so this would.
original loop. Good. Okay, so now I goes from 1 to length nums minus 1, right? Inclusive.
Sure.
From line 20, you're going anywhere from 1 to len num minus 1, right?
Yeah.
Okay, but if you go to len num minus 1, which is the last index, and you try to do I plus 1, you're going to be out of bounds.
Exactly. That's why I'm trying to catch that case.
So the elif should only limit from the right side.
It is only limit from the right side. It's I plus 1's greater than or equal to nums.
But that's the case where it doesn't do anything.
Yeah, that's what I'm saying. I need the opposite
No,
case.
you want the case where it does do something. So you should do I less than that.
Yes, I need the opposite side. So it's just less than? I plus 1 is less than nums. Then you do this logic. Okay, yeah, that makes sense. Okay.
Minus 1.
Wait. Why is it minus 1? Oh, you mean let it?
Well, because if I minus 1, sorry, if I plus 1 equals length of
Nums.
Oh no, then you're good. You're good.
Yeah, as long as I plus 1 is less than nums, then you won't get out of bounds. Yeah, okay. So if
then now you check.
Now you do the logic. Yeah. So if okay, it would be, so you found the mistake on your index. So your index is I, because your I is greater than less than your previous number. Okay, yeah. So if nums I minus 1 is okay, I minus 1 is greater than nums I plus 1. That means you have to check the other case. So it's and yeah, nums. The problem is I minus 2 might be out of bounds too, so I have to check for that.
Well, then you can make a further nested thing, right?
I mean, I can, but alright.
Okay, then yeah, you can just do I minus 2 greater than or equal to 0.
Yeah, and wait, okay, so this case would only trigger. Okay, but wait. In this scenario, right? Oh wait. If it's out of bounds, you're guaranteed to be able to flip that one. So it should handle this case. Okay, that's fine. Okay, and nums minus 2 is greater than nums I. Okay, so it was I minus 1 is greater than I minus 1 is greater than this, and I minus 2 is greater than this. Yeah. So this both happens, return false. And that's it. Okay, I think that's fine. Alright, looks good. Alright. That was a long time.
Yeah. I mean, I think it's very tricky. You have to understand what the hell's going on, right?
Yeah. Like this, the algorithm without the edge cases is super easy, but the algorithm once you have edge cases, you have to figure out why. I mean, in the example it's super easy, but I guess figuring out how to do an algorithm is more difficult.
Okay. Yeah, I mean, I tried to get you to go through the examples and be like, why is it that you cannot change the one before, or why can you change the one before, right?
Yeah.
And you sort of got it, but not really. I don't know. It's just kind of tricky to think about.
Alright.
All right. Cool.
Alright, thanks. Bye.